Hey, welcome back. Let's get started. So in terms of what we've been up to for these 2 weeks, this has been primarily looking at the next few items to be done to remote control the vehicle. And so like last time we talked about getting what kind of systems were going to be put together, and this time we have them designed. So let's take a look at that. Let's start with electrical systems. And Gabe's got a pretty good sort of rundown on what's been going on there.
Okay, you're rolling. Hello, and welcome to my laboratory. Alright, real talk though. So, we tried a couple circuits. They probably can't see, maybe you can. They're on the whiteboard. One's in blue, one's in orange. Fun fact, they both failed.
Good tease.
We've hit a really big roadblock. See that noise?
Huh?
Yeah?
Uh-huh.
Okay. I'm gonna unplug the car. Oh, by the way, careful with these wires. We've routed it.
They go to the car. We didn't feel like
So,
moving.
look, I'm gonna unplug this. Noise goes away. Alright, whatever.
Power to the car.
So, the car is off, by the way. Can you
Turn on the car.
Can you hit that switch? See that? So, you've turned off the car, we've plugged in the car back in, but the car's off, okay? The capacitor responsible for the low pass filter, we unplug it, we plug it back in, we have this. We unplug the car and plug the car back in, we have that.
What does it mean?
I don't know. We don't know. We don't know why it's happening. Not the end of the world. We actually think we came up with a simpler solution, but before we delve into that, let's talk about what's actually happening in front of me. Basically what's happening is that, let's pretend that this computer here is actually like the car's computer, because it will be. And so when the car takes in data from all of its sensors, it like turns it into a huge mess and then filters that data and then it goes down with a bunch of data and it filters it down to a single point. And that single point is a message telling one of these microcontrollers to tell one of the actuators to do something. So, for example, let's say there's a wall in front of us and we want to stop, right? So if we want to stop, they would take in all that data, it would give it to a single point, and then it would tell the car to stop, and the car would stop. So let's turn that car on. Actually, first I'm going to reset the program. Okay, and then I'm going to turn on the car. The car's on, and so let's say it takes in all this data and it's like, go car. So when it says go car, the brakes have moved, so they let off the brake, and the car started to go. So then they're off, so then the system's like, car go faster. Right? Car is off. And now, the system's like, I'm gonna crash. So now the brakes actuate there, and the car stops. So that's the idea. So now, this basically, the computer will take in all the data. So the computer on the call will take in all the data, like big data, and filter, process what we're gonna do with it, and spits out a message that's like 5 characters long, which is what actuator I wanna control, and how fast do I wanna control it. So how do you differentiate between autonomous control and manual control? I'm glad you asked. Well, we're working on it. Basically what I've done is I've taken a diode here, which isolates my circuitry from the car circuitry. Diode is this guy. Diodes are cool because they allow currents to flow one way. They do not allow currents to flow the other way. So whatever voltage and current is happening on one side, basically if the pedal is pushed, that doesn't screw up our circuitry here for autonomous.
So, major focus of this week has been production design, of course, and our braking system is currently in production. We went to the machine shop to do that.
So we got the linear actuator that gets bolted in right here.
Yeah.
And the forces are pushing out like that. So we got like this member to like kind of transfer that in this nice triangulation. But like, look at this little guy. It's wrong with this picture? I need this guy to be this guy. Right?
Mm-hmm.
Which means I'm gonna cut it out and tape it on and then line it and cut it.
Okay. Woo what?
What?
Do it again.
Woohoo.
Come on, show me the fist pump again.
Woohoo.
Yeah, okay. Cool.
And the basic idea is to have the brake be actuated by the linear actuator pushing into the brake pedal in such a way that it would allow us to be able also to press the brake pedal at the same time if the human operator would need to at some point. And so far as the steering, we finally got our measurements straight. Oh my goodness, this thing. And which means we were able to get our interfaces all printed and designed. These will eventually be machined in metal, and this hole right here is where the 4-bar will attach so that we can toggle in, toggle out to engage and disengage the steering. Real nice and easy. Why are we using a 4-bar? Because when we hit the 4-bar toggle point, then there's so much force onto the 4th bar that it will lock our motor into the steering shaft, kind of like one of these, how these work. This is a vice grip in case you don't know, but you should. If you didn't, it's a vice grip. And how a vice grip works is that it uses the exact similar concept where when you press this 4-bar, so 1, 2, 3, 4 bars down, the grip part locks in place because that is the bar that is moved in the 4-bar. And now, no matter what you do, if you judder this, you can't move it because these 2 bars are currently in the locked position, the locked toggle position. Now, we can force this 4-bar out of the toggle position by pressing here and leveraging it right outside of the toggle position. It will snap out because there's a spring right in here that allows it to do that. And that's how we want to do our toggling, because that's exactly the kind of motion that we're looking for our steering, and that's kind of the basics ideas of that. We also got the mail today, and in the mail, in this lovely box we have, and love getting mail, we got this. Our HiPack sent us a lovely LiDAR from Velodyne, and so thank you so much, HiPack. This is fantastic. This LiDAR also has the capacity of being able to take GPS signals and make those GPS signals a part of our data, which will save us a huge amount of time when it comes down to the data crunching. So thank you so much, iPack. This is amazing. We did play a little bit with the Tesla vehicle in order to do some hallway mapping. Now right now we don't have the data the data output for the hallway mapping stuff, but it's fun, right? Oh my God, it has a horn.
It has lights.
It's got headlights too. Legit? No, like legit, you look like a Mario Kart character right now.
You actually could be a
Like, I kind of want to overlay the 3, 2, 1 in the Mario Kart sound. It should be like,
Mario's.
Wait, keep going.
Make it right slowly.
And that's all we got for these 2 weeks. The aim is to get this vehicle to drive by wire in 3 weeks' time, and that's the plan. So thanks so much for tuning in. If you enjoyed this, give this video a like, and that'd be fantastic. Stay tuned for our next update.